students. I am a PhD student in electrical engineering, and the topic of my presentation is design implementation of supervisory control for integrated bus converter. This is a part of my research topic in my PhD project. I am to introduce about the power electronics generations, power segmentation, and describe the behavior of the DC-DC bus converter and the integrated bus converter. Then the strategy of supervisory controller, and finally experimental research. Power electronic generation. Power electronic is a branch of the electrical engineering that deals with the control and management of the power in electrical and electronic systems. Currently, there are a big interest in the integration of the alternative sources with traditional electrical sources. But the need to integrate alternative sources with current electrical sources is by means of a device of electronic devices. The name of these devices is converters. But the integration of the power electronics in distributed generation bring a challenge to the design of the converters. In this case, a traditional way to design a converter is just with one converter in a power converter centralized. We have a source of power in and power out. And the converter deals with the power between the input and the output. But when we work in distributed systems, we need to deal with several sources with different behavior, and for this reason we need to decentralize the converter and with an intelligent converter. The intelligent converter is a converter that is built by several single converters. The advantage of working with intelligent converter is that with intelligent converter we have more flexibility, and they can work with several sources and different levels of powers. This is an example of some configuration, and I am working in this kind of configuration. This configuration, I have one sources, several converters, and the out. In this case, the power is shared with each converter. In order to design the converter, we have the electronic model of this converter. In this model, we have the sources and the output. The sources is a battery, in this case, and we have two variables, the voltage and the current. The voltage represents the force of the electrons, and the current is the measurement of the number of electrons. In this case, we have an element to control the power. This is a MOSFET, it's a transistor, and in this case, we have a speed view and signal. This signal have two levels, a high level and a low level. In high level, the circuit have this configuration, and in the low level, the system has this configuration. Each of one, this configuration have this models, mathematical models, and when the model is solved, we have the relation between the voltage out, voltage in, and the efficiency. When we work with an interleaved bus converter, we have several converters, one sources and one load. In this case, this is a mathematical expressions. We have a constant voltage. The current is shared with the converter, and as a conclusion of this is that the equivalent load is in converter is m times the total load, where m is the total number of converters. In this case, the most important resource is that the each converter have an equivalent load that share the current between each one. The efficiency of the system is given by these expressions, and I found that when we have the Linux converter configuration, that the total efficiency is equivalent to the efficiency of one converter with a load of this expression, where n is the total number of converters. In this case, I made some simulations, and I find that with a high number of individual converters, the system has a better efficiency. In this case, the system has 4 converters, and the efficiency is near to 70%. With 60 converters, the efficiency increased to 90%. This is an proof of the efficiency of the system. The strategy of control for increase the number of converters is denominated the supervisory control based on Petri nets. This is a Petri net that controls the system. Basically, the system supervises one parameter of the system and plug converters depends on the requirements of the load. If the load increase, the system plug more converters, and if the load decrease, the system unplug converters. Finally, I made the implementation, and I can prove that when one almost converted has a low efficiency when the requirements of the power increase. But in interleaved bus converter, with the methodology proposed, when the load increase, the efficiency is improved. In this graphic, we have the behavior with one converter, 70%, 2 converters, and with 4 converters, the efficiency of the system increased to 90%. In conclusion, interleaved bus converters show better characteristics of water regulation and efficiency in comparison with individual bus converters. Equivalent load interleaved bus converter is n times the total load, where n is the total number of converters, and the total efficiency of an interleaved bus converter is equivalent to the efficiency of one converter with equivalent load. And the strategy of supervisory control based on Petri nets is keeps the converter in a stable operation zone with high efficiency. for instance. Thank you.